Howdy folks, we are going to get into 9.2 for Math 120, which gets into curves, polygons, circles, and geometric constructions. Now you can see geometric constructions are crossed out because we're not going to be doing them. So yay! Now if you're curious though, geometric constructions are basically looking at drawing geometric shapes using only a straight edge and a compass and a pencil. So, but we're not going to get into those. So you're out of luck if you wanted to do those. Okay, let's get into some of the terminology. So we got curves. There are 4 types of curves based on 2 descriptions. So simple and closed. So what are those definitions? A simple curve can be drawn without lifting the pencil from the paper and without passing through any point twice. Okay, and then a closed curve has its starting and ending points in the same and is drawn without lifting the pencil from the paper. Okay, so now, all right, that sort of makes sense, maybe not. Let's see what some examples are. Now you can have some combinations of those 2 definitions. So the first one is going to be simple and closed. So it's going to satisfy both of those conditions. So you could have something that looks like, you know, sort of like a racetrack type of thing. And it doesn't have to be wavy, curvy at all. It could be straight lines. So you could have, you know, something that looks like, you know, that. I mean, the big thing is that you can't really discern where you started and where you ended. And I never lifted up my pencil at all. I didn't cross over myself at anywhere. Now, for the next one, simple and not closed. So we could have something that looks like that. Again, not anything fancy, but I don't cross over myself. That's what makes it simple, is I don't cross over myself. And not closed, you can see there's a hole. I didn't end where I started. So, and again, it doesn't have to be curvy lines. It could be straight lines. So that would also be simple and not closed. All right, so now if we looked at not simple and closed, okay, so not simple means it crosses over itself, but closed means you stop where you start. So if we wanted something curvy, we could do just like a figure 8. So I crossed over myself here, and I stopped where I started. And likewise, you can have something that looks like this. That would be simple, not simple and closed as well. And then the last one rather is not simple and not closed. So you kind of have a combination of these 2 things in a way. So you could do something like that, and then you could do something like that. So it crosses over itself and it's not closed. So, okay. So there's a lot of different types of curves we can have, but really the most interesting ones are going to be the closed ones. But you can kind of see that it gets a little messy when they're not simple. So we're going to just focus on this first category of shapes. So they're going to be simple and they're going to be closed. All right, so now within that, just that realm of shapes, we can also classify them as convex or concave. All right, so a simple closed curve is said to be convex if a line segment formed from 2 points within the figure is always contained in the figure. If the figure is not convex, then it's concave. All right, so really we've got to have a solid understanding of what this definition for convex means. All right, so let's take a look at a couple pictures. So if we had convex, so something that looks like this, and I'm going to use straight lines just because it's a little bit nicer. Okay, so we have a shape that looks like this. Now let's see why it is convex based on this definition. If a line segment formed from 2 points within the figure, so if I were to grab any 2 points and then I connected them with a line segment, I'd have something that looks like this. But now, no matter where I put those two endpoints inside, that line is always inside the figure. So I can move it around and everything, and it doesn't get outside of the shape at all. So that's why it's convex. So if I wanted a concave one, I could draw something like this. So here we have some parts of it that are convex, but not the entire shape. And we can see that if I grabbed a point down here and then another point down here and connected it with my line segment, now my line is outside of the shape, and that's no good. So there's kind of like a dent in there. That's another way to think of it. There's a cave in that shape. So there's a dent, and that's what makes it concave. All right. Now, again, we're not going to be dealing with these types of shapes. We're really going to be dealing with the convex ones. So we've kind of narrowed down our field quite a bit, and we're going to narrow down even more. Instead of looking at wavy, curvy type of shapes, we're going to look at those straight line shapes. And when we do that, they're called polygons. So anytime they have straight line sides like that, and it's convex, we're going to be dealing with polygons. So a polygon is a simple closed curve that is only made up of line segments. Pretty basic definition. And we can have all kinds of different types of polygons based on their number of sides. So some of these you should know, some of these you might not, which is fine. 3 sides is a triangle, 4 is a quadrilateral, 5 pentagon, 6 is a hexagon, 7 is a heptagon. So that's kind of a weird one that most people don't know. 8 you probably know is an octagon. 9 is another weird one. That's a nonagon. Okay. And then 10 you might know that one, a decagon, sort of like a decade. It kind of, rings true with that. So just out of curiosity, do you know what a 12-sided one is? If you had a 12-sided one, that's actually a dodecagon. So we're not going to get too crazy with these, but there's all kinds. They have names for many, many, many sides. So, and like I said, we're not going to get into all that, but just in case you're curious. Okay, so what else can we do with polygons? Well, we can look at special polygons that are regular. So when they're regular, they're going to have all the sides and all the angles are going to be the same, or they're going to be equal. So all the sides are equal to each other, all the angles are equal to each other. All right, well, that's nice, but what does that look like? Well, I'm glad you asked. So if we wanted a regular triangle, that would look something like this. Now, it's not perfect by any means, but how we can kind of infer that it is a regular polygon, we can put a little dash in each side, a single dash. So that's kind of a way that they would signify that they're all the same length. And very similarly with their angles, if we put a little arc in the corner, that would also help signify it. And then sometimes they'll even put an extra little line in those arcs. Now, how they would say that they're truly different is they would add more dashes. So one side might have 2 dashes, one side might have 3 dashes, and that's different than one that has only 1 dash in it. So that's kind of the way they do that. What about a regular, oops, if I can spell right, a regular quadrilateral? I know you know this one. A regular quadrilateral. So again, quadrilateral is 4 sides. All the sides are the same length. All the angles are the same. You know that one. It's a square, right? It's got to be a square. So a square is a special type of quadrilateral, and we're going to explore all kinds of quadrilaterals in a little bit. So, and we know what a square looks like, right? So again, all the sides are the same length. Try to get them the same length. And we can put a line in each side. And we can put a little right angle in each corner. So yeah, we know what a square looks like, but that's an example of a regular polygon, a regular quadrilateral. Okay, so let's stop there, and then we'll pick up looking at some triangles in the next video. See you in a minute.